A geometric sequence is a set of numbers in which the numbers they have a common ratio between them. For example, let's say I have a geometric sequence with the terms respectively a1, a2, a3, a4, a5, a6, a7, seventh term, and eighth term. So now a2, second term, is given when a specific number is multiplied with the first term. I get the second term. This number is noted by a symbol R. Now this R stands for common ratio. Just like in arithmetic sequence, we have a symbol D for the common difference, which was given when the term was subtracted by its previous term. Now in this, the common ratio is given when the term is divided by its previous term. For example, R will be given by an over an minus 1, or R is an plus 1 over an. In either way, you're dividing the next term by the previous term, right? So an example of a geometric sequence is, let's say, 1, 2, 4, 8, 16, 32, 64, 128. Now here you can see that the previous term is being multiplied by 2 to give the next term, right? 2 times 8, 16, 2 times 16, 32, 2 times 32, 64, 2 times 64, 128. So our common ratio is 2 divided by 1, 2. Right? Now this was the formula for finding the common ratio of a geometric sequence. First we have to recognize whether the sequence is an arithmetic or a geometric. In your A levels, there is only an arithmetic sequence and a geometric sequence. There are no other sequences apart from these two. Right? So these two formulas are for finding the common ratio. Now moving onwards to the formula for finding the nth term. That formula is an, or nth term, first term a multiplied by the common ratio raised to the power n minus 1. So this was our 8th term, right? Now if I want to find my 9th term, what I'll do is a9 equals to a, the first term was 1, into common ratio is 2, 9 minus 1, right? 2 power 8. So that will give me 256, right? So this is our 9th term, and this is the formula for finding the nth term of a geometric sequence. Now there are actually two types of geometric sequences. One is divergent, other is convergent. Divergent geometric sequence, they diverge, like they don't converge to common value. For example, this, it is 2, 4, 8, 16, 32, it is moving on, it will keep on moving on, alright? And the same goes for this, 10, negative 20, negative 4, 10, negative 20, positive 40, negative 80, and so on. It is also not diverging to a value. The ratio of this geometric sequence is 2. Common ratio in the ratio of this geometric sequence is negative 2. Yes, ratio can be negative. Common ratio can be negative. Now these two sequences, these are convergent geometric sequence. Now here you can see that 2, 1, 0.5, 0.25. This is actually converging to the value of 0. As you progress, the values, the terms of the convergent of this geometric sequence, they converge to the value of 0. They get closer and closer and closer to the value of 0. And same goes for this one, 8, negative 1, 1 by 8, negative 1 by 60, 1 by 28, 1 by 28. Here also the terms are getting smaller and smaller and smaller until eventually they reach the value of 0 at infinity. So the common ratio for this is 1 by 2. If you divide 1, the next term, the previous term, will get 1 by 2. Or if you divide 0.5 by 1, you'll get 1 by 2 again. Now the common ratio for this term, for this sequence is negative 1 by 2. Negative 1 by 8. Not 1 by 2. Negative 1 by 8. Right? So it doesn't matter common ratio is positive or negative. The sequence can still converge. All it depends is on the magnitude of the common ratio. For example, here the magnitude of the common ratio in these two is less than 1. Right? This is 0.5. This is also less than 1. It must be 0 point something. And here the common ratio of the sequence is, the magnitude of the common ratio of these two sequences is greater than 1, right? The size of the common ratio, right? No matter what the sign is, these two lines, they represent the modulus. Modulus, they represent the magnitude. For example, if I want to find the modulus of negative 2, what I'll do is, I'll take the square of negative 2 and then take its under root. So the square of negative 2 is 4, positive 4, and the under root of positive 4 is 2. So modulus of negative 2 is 2, right? So here, the modulus, if the modulus of r is greater than 1, the sequence is divergent. If the modulus of r is less than 1, the sequence is convergent. Now, the formula which I just told you of the nth term, an, a, r, n minus 1, it can be used for these two sequences, right? These two types of sequences, this formula can be used. Now, but for finding the sum or the series of these two sequences, we have different formula. For divergent sequence, we have this Sn. If I want to find the sum of the n terms, first term a, r raised to the power n till terms I want, this is the number of terms I want to find the series, minus 1 over r minus 1. This is for the convergent sequence. Now for the divergent sequence, we have this formula, Sn equals to a equals to a 1 minus rn, r to the power n, over 1 minus r, right? Now, as I've told you that this convergent sequence, it is converging to a specific value. It may be 0 or it can be any other value too. Now, the sum to infinity of this series will be a fixed number because they are evidently converging to a fixed value, right? And the sum of infinity of these divergent series will not be a fixed number. Like, we cannot find the sum to infinity of divergent sequence, but we can find the sum to infinity of a convergent sequence. Why is that? Because as this n gets bigger and bigger, the value of r gets smaller and smaller because r is less than 1. For example, let's take r equals to 1 by 2. Now what will be r cube? 1 by 8, right? What will be r is above 5? 1 by 32. So this value, this term is actually getting closer and closer to 0 as n approaches infinity, right? So the sum to infinity of a convergent sequence will be a, this will get to 0, 1 minus 0 is 1, and 8 and 1 is a, over 1 minus r. So this is the formula for the sum to infinity, which is only applicable if the sequence is a geometric convergent. This is for sum to n terms of a geometric convergent sequence. The one in the yellow color is for the sum to n terms of a divergent sequence, and sum to infinity is the formula for sum to infinity of a divergent sequence doesn't exist. And going up, this is the formula for finding the common ratio in the blue color, this one or this one. You could use either this or this, it doesn't matter, it will give you the same answer. And this is the formula for finding the nth term of the geometric sequence.